All right, let's dive into the world of deep learning. But we're going to do this a little differently. Forget the heavy math textbooks for now. We're going to jump right in and actually build things. It's time to demystify this amazing technology hands-on.
And you know this quote from Curtis Langlotz at Stanford? It really nails what we're all about today. It's not about memorizing formulas. It's about getting your hands dirty, exploring, and really understanding by doing.
So there's this myth, right, that to get into AI, you need a PhD, years of abstract math, that it's this exclusive club. But what if that's just not true anymore? What if that's, well, the old way of thinking?
Okay, let's break this down. On the one hand, you've got the old way. Hit the books, study complex theory for months or even years, and then, finally, maybe you get to write some code. The new way, it flips that completely on its head. We're going to build something that actually works first. Then we'll use it to solve a real problem. And along the way, we'll learn the theory we need when we need it. It's just so much more intuitive, and honestly, it's a lot more fun.
So let's get our hands dirty and score that first victory. I'm not kidding. We are going to build a real, world-class AI model right now, and it's only going to take a few minutes.
So here's our mission, should you choose to accept it. We're going to teach a computer how to tell the difference between grizzly bears, black bears, and, well, teddy bears. Yep, you heard that right. Okay, first things first. Every single AI model out there needs data. So our first job is super straightforward. We just gather a bunch of pictures for each of our bear categories. A quick image search will do the trick. This collection of images, that's our training ground.
Now you're probably picturing pages and pages of crazy complex code, right? Well, with modern libraries like Fast.ai, training a state-of-the-art model, it takes just a handful of lines. Seriously. The tools today are designed to let us focus on the problem itself, not on writing endless boilerplate code.
And boom, here's the payoff. After just a few minutes of training on a pretty standard computer, our model can tell these bears apart with over 99% accuracy. That is an incredible result, especially for how little work we just put in.
But wait, it gets even cooler. Let's actually dig into the model's so-called mistakes, the pictures it was the most confused about. For example, look at this one. The model predicted grizzly, but our original label says it's a black bear. But, I mean, come on, you and I can both see it. That looks a lot like a grizzly bear.
And that right there is the big aha moment. The model is so darn good that it's actually cleaning our data for us. It's pointing out the images that we messed up when we labeled them. Instead of trying to get perfect data before we start, we use the model itself to help us find and fix the problems. It's a total game changer.
Okay, I know what you're thinking. This feels like a magic trick, right? How in the world did we get over 99% accuracy in just a few minutes with a few lines of code? Let's unpack the magic. The secret sauce here is a technique called transfer learning. Think about it. We're not teaching a baby to see from scratch. We're starting with a model that has already been trained on millions of images from the internet, so it already knows about edges and colors and textures, even things like fur and eyes. All we have to do is fine-tune that existing knowledge for our specific job, telling bears apart. It really is like a master chef. They don't have to relearn how to use a knife for every new dish they create. Okay, so we're bear experts now. Big deal, right? Well, what's wild is that this one skill, classifying images, can be used to solve a whole universe of problems that you would never expect. Let's expand our horizon.
Check this out. What if I told you that you could literally look at a computer virus? Researchers found that you can take the raw code of a piece of malware and turn it into an image. And different types of malware create different visual patterns. All of a sudden, a cybersecurity problem becomes an image classification problem, and we know how to solve those.
And it's not just for things that are, already pictures. Take a boring old sales spreadsheet. You can plot that data on a graph, right? Well, what is a graph? It's an image. Suddenly, our image classifier can be used to spot sales trends or find weird anomalies in business data.
And it goes even further. This is the same underlying idea that powers those recommendation engines. The ones on streaming sites that somehow know exactly what movie you want to watch next. It's all about finding patterns, and that's what these models are brilliant at.
So, we've seen how powerful and flexible this all is. But this is where we have to pause and have a serious conversation, because with this kind of power comes a huge responsibility.
Look, the algorithms aren't evil. They're just really, really good at whatever job you give them. And if we're not incredibly careful about what that job is and how they're allowed to achieve it, we can accidentally create some really dangerous feedback loops.
Let's take a recommendation engine as a perfect case study. Its goal is super simple: keep you watching. That's it. But then it starts to learn things about us.
It might figure out that extreme or sensational or even conspiratorial content is really good at keeping people glued to the screen. So because it wants to do its job well, it starts recommending more and more of that stuff. Someone might get nudged down a rabbit hole, not because the system is malicious, but because it's only optimizing for one thing: engagement. It's a really tough and important design problem to think about.
So, you've seen the technique, you understand the power, and you've seen the potential pitfalls. The foundation is there. So, what now? Where do you go from here?
Here's my main piece of advice. Don't just study this stuff, do it. Become a practitioner. The absolute best thing you can do right now is to just start your own project. It doesn't have to be perfect, doesn't have to change the world. Just pick something you're curious about, find some data, and start building. The goal is just to get started and to learn as you go.
We started this whole thing by tearing down a myth, the idea that you need years of theory to even get started. You've just seen that you can build something truly powerful in just a few minutes, and you've seen how that one skill can unlock all kinds of problems. So the question is no longer if you can build this stuff. The real question is, now that you can, what will you create?